Good morning, my Famer fellows. It's a privilege to be here with you today. We're going to explore the principles and practice of simulation-based education. Not just the tools, but the why and how behind effective simulation. Let's begin. Let me first introduce our team. We are Group 2, a collaborative group of educators and medical trainees passionate about innovative teaching methods. Each of us has contributed to designing this module and the simulation session you'll learn about today. It was all possible through the invaluable guidance of Professor Hani Wahib. By the end of this module, you will be able to explain the role and value of simulation in health professions education, select appropriate simulation modalities based on your learning objectives and available resources, design structured simulation scenarios, including briefing and learner engagement strategies. Apply effective debriefing and feedback techniques to enhance reflective learning. These objectives guide everything we do today. This is the roadmap for this 2-week course. Over the 2 weeks, this course introduced learners to simulation-based medical education, SBME. Week 1 provided an overview of SBME, including its role in clinical training and patient safety. Week 2 outlined the practical steps for designing an effective simulation-based session, from learning objectives to debriefing. The teaching materials included recommended and optional readings, video demonstrations, PowerPoint presentations. The learners had pre- and post-tests, and a practical assignment to reinforce learning. By the end of the 2 weeks, participants gained foundational knowledge in both the theory and application of simulation-based medical education. As part of the course, the fellows completed a core practical task, designing a basic simulation-based learning session. Each ML Web group was assigned to a single clinical or educational topic and developed a complete session plan. The goal was to create a plan that a facilitator could pick up and implement right away, using only standard simulation resources, such as mannequins, task trainers, or standardized patients, typically available in most simulation centers. The final output included learning objectives, a scenario outline, a debriefing guide, and necessary facilitator notes. All tasks were graded using a provided rubric, which assessed clarity, educational alignment, feasibility, and the integration of simulation best practices. Now, let's review some of the most important points covered in the course. Simulation is a technique, not a technology, to replace or amplify real experiences with guided experiences that evoke or replicate substantial aspects of the real world in a fully interactive manner. Simulation in medical education offers numerous benefits. It enhances patient safety by allowing practice without risk to real patients and reduces medical errors in clinical settings. It improves clinical skills through repetition, leading to mastery and confidence. It provides a safe learning environment where learners can make mistakes and learn from them without real-life consequences. It promotes critical thinking by encouraging clinical reasoning and decision-making, including exposure to complex and rare cases. It enhances teamwork and communication through interprofessional education, improving leadership and collaboration skills. It enables standardized training, ensuring consistent learning experiences for all students and proving useful for assessments, such as OSCEs. It provides immediate feedback and debriefing, facilitating reflection and self-improvement through structured feedback that enhances learning outcomes. And finally, it bridges theory to practice by connecting classroom knowledge to real clinical practice, preparing students for real-life scenarios. Simulation is more than just mannequins. It spans a wide range of educational methods, from simple task trainers to complex interprofessional team scenarios. The key point here is that the choice of simulation must be driven by learning needs, not by what technology is available. Let's look at the different uses. Simulation has wide applications in medical education. It is used for procedural skills, clinical reasoning, team training, assessment, and preparation for rare but high-stakes events. Importantly, Simulation allows learners to practice these skills in a safe environment without risk to patients. Fidelity refers to the degree of realism in a simulation activity. It is a multi-dimensional concept that includes physical fidelity, psychological fidelity, and conceptual fidelity. High realism is not just about equipment. It also involves emotional engagement and clinical accuracy. It is essential to understand that high fidelity in one dimension does not automatically imply high fidelity overall. For example, an IV arm may have excellent physical fidelity, but limited psychological fidelity. Most importantly, high fidelity does not always mean better learning. Fidelity should always match the learning objective. Beyond fidelity, we also consider immersion and interaction. Immersion refers to how closely the environment resembles real clinical settings, while interaction reflects how actively learners engage with the scenario. High-quality simulation usually combines meaningful interaction with appropriate immersion. Simulation in medical education faces several key limitations: a lack of high-quality experimental evidence validating its utility, difficulty integrating into crowded curricula and demonstrating patient outcome improvements, challenges in tailoring training to individual learner needs, infrastructure and resource constraints, including specialized facilities and ideal instructor-to-learner ratios, technical difficulties, with simulators failing to replicate real physiological responses, ethical and medical legal concerns regarding consent, confidentiality, and inducements, high costs for equipment and maintenance, limited long-term outcome data beyond short-term gains, restricted access to suitable patients or realistic models, and questionable transferability of simulation performance to real clinical competence. Now, let's walk through a structured process to implement a simulation session. The first step in designing a simulation session is conducting a needs assessment. This involves identifying gaps in learners' knowledge, skills, or attitudes, using data such as clinical outcomes and feedback, and aligning the simulation with institutional and curricular goals. Clear learning objectives guide every element of simulation design. Well-written objectives define what learners should be able to do by the end of the session and determine the appropriate modality, fidelity, assessment, and debriefing approach. In this step, we select the simulation modality, prepare the environment, ensure faculty readiness, and organize materials. Careful preparation ensures that the session runs smoothly and supports the intended learning outcomes. A high-quality simulation script is realistic, standardized, and goal-directed. Scripts guide what participants say, how they behave, and how emotions are portrayed. This consistency is essential for fairness, reliability, and educational effectiveness. The script is the story of the simulation. It includes patient presentation, age, history, vital signs, triggers, what changes to push the learner forward, expected actions, what should learners do at each step, branching, what happens if they do X versus Y. A good scenario is like a good lesson plan. It has structure, but allows for learner-driven variation. Scenario design can be approached using storyboarding or structured templates. Established templates ensure inclusion of key clinical information, scenario flow, roles, and pre-briefing instructions, making the simulation reproducible and scalable. The script includes clinical context, patient profile, baseline state, environment setup, scenario cast, and triggers. Together, these elements create a coherent and reliable learning experience that responds dynamically to learner actions. Step 5. Conduct a pre-briefing. Never skip this. Pre-briefing sets psychological safety. You tell learners, this is a learning space, not a performance space. We will make mistakes here. That's the point. There will be no punishment for errors. You also review logistics, time limits, roles, equipment, and the fiction contract. the agreement to suspend disbelief and engage as if it were real. Before full implementation, pilot testing helps identify logistical issues and refine scenario flow. During the actual session, facilitators observe learner actions while maintaining the integrity of the scenario. This is the most important phase. Without debriefing, simulation is just an activity, not education. Debriefing is where learners reflect on what happened, why it happened, and what they would do differently. Use frameworks like what went well, what was challenging, gather, analyze, summarize, or the plus-delta model, what worked, what would change. A rule I follow: debriefing should be at least as long as the scenario itself. If you run a 10-minute scenario, spend 10 to 15 minutes debriefing. We'll move to step 9, evaluate and improve the session. You need to evaluate multiple components. Learning outcomes. Did learners achieve the objectives? Simulation design and realism. Was fidelity aligned with purpose? Learner engagement and participation. Were they actively involved? Facilitator performance. Did we set the right tone? Debriefing quality. Was it structured, safe, and deep? Learner confidence and satisfaction. Do they feel readier for real practice? Use this evaluation data for continuous quality improvement. Simulation is not a one-and-done event. Each iteration should be better than the last. Step 10. Integrate simulation into clinical practice. This is where many programs fail. They run a great simulation, but then never connect it to the real clinical environment. To truly maximize value, simulation must be seamlessly integrated into the broader clinical learning ecosystem. That means linking simulation objectives to clinical rotation goals, having clinical preceptors reinforce skills seen in simulation, using simulation to address real adverse events or near misses from the hospital, creating a spiral curriculum where skills are revisited and deepened over time. Skills gained in simulation must be directly applicable to the bedside. Otherwise, why are we doing this? So, my FAMR fellows, let me bring this all together. We have learned that simulation is not about the most expensive mannequin or the fanciest lab. It is about intentional design, psychological safety, and alignment with learning goals. We have learned that fidelity is multidimensional, and that high fidelity in one area does not guarantee it in another. We have learned that debriefing is the heart of simulation. Without it, there is no deep learning. And we have learned a 10-step process to design, deliver, evaluate, and integrate simulation into real clinical practice. Now, I want to leave you with a call to action, something practical you can do when you return to your home institution. Think of one simulation you currently use, or one you wish to create. Ask yourself, is the fidelity matched to my learning objectives? Am I using technology because it's needed or because it's available? And does my debriefing truly allow learners to reflect and grow? If you change nothing else, improve your pre-briefing and debriefing. That alone will transform your simulation education. Thank you, my friends.